Well, hi there. How's it going?
Yeah, it's going good at I'm joining from different locations. I'm in UAE, so it's actually night 2 a.m. in the morning.
Okay, wow. Well, thank you for taking the time to come and join us. I really appreciate that, especially yeah, at that time. That shows a lot of commitment. I like it.
Yeah,
Would you mind saying your name one more time for me?
sorry.
So Reach, maybe you would type it in the chat for me too, because I really, it's important to me I don't mispronounce your name.
Yeah, my name is Rakesh Gupta.
Okay, great. Well, and let's see. Iotaji, am I saying your name right? Welcome.
Yeah, thank you.
I'm gonna give a couple more minutes for some people to join, but I don't believe we've met before. So if you, Rakesh, thank you, Rakesh Gupta. Okay, I really appreciate that. It's important to me when we can chat name to name. Tell me a little bit about where you guys are at in your CISSP journey. What brought you to the group?
Yeah, for me, Ayodeji, I'm trying to see I can. Um, I mean, I'm trying to see how I can put myself together and challenge the exam sometimes later this year. And I've been trying to read the materials for some time now.
Okay.
Yeah, and somewhere along the line, I stumbled on the group and I joined the group, and I think the group has been good so far. So
Good.
that's
Well,
that's my journey.
and you're wanting to take the exam sometime this year, you said. Did I hear that?
Yes. Yeah.
Okay. Great. That's awesome. What do you do for work right now?
I do internal audit function, as it were.
Okay, gotcha. Great,
Yeah.
great. Well, if you have areas where we're talking about something and you know something that I don't, then feel free to speak
Sure.
up. I love that. So, hi, Cheryl. Good to see you.
Hello.
And Rakesh, your exam is coming up here quick, about 5 or 6 weeks away. Okay, 31st of August. All right.
All the
Excellent.
best.
Good job getting it scheduled. Sometimes actually scheduling and paying for the exam is the hardest part. You already put a lot of time and effort into getting ready.
Hello, Paul.
Paul, good to see
Hey
you.
guys. Yeah. Hey guys, how you doing? Thank you.
Good, good. Saravan, thank you for being here. I know you and I didn't really get a chance to chat last section.
Not, yeah, maybe.
Yeah, well, it's I think you were on the last session, so looking forward
Correct,
to
correct.
yeah. Do you have a test date scheduled, by the way? I'm trying to kind of keep that in mind.
Yeah, I'm gonna do it, and because I have a voucher, I need to do it. This is my second attempt, though.
Second attempt. Okay.
Yes.
Yeah.
Yeah, I got to do it probably
Yeah.
next month. Yeah.
Okay. Cool. Well, good deal. Well, we'll go ahead and get started. Some more people might come and join us here, but so my name is Josh. If I haven't met you, I've chatted with the majority of you here. I am CISSP certified. I got certified in 2021, I believe, and just recertified here just recently through credit or the continuing education credits that they have. So when you get to that stage, come talk to me because we want to continue supporting you in that stage of things too. I have my master's degree in cybersecurity and information assurance, and Vincent, who started this group, brought me in to kind of help out with the education side of things. He really takes the community aspect important, much more seriously. I take it very seriously as well, but that's his focus, I should say. So if you have questions or comments, or reach out through the school platform to Hirai. He couldn't be here this evening, but you're welcome to send him or I messages directly on there. And what we're going to chat about tonight is driven from the community. Some of you had spoken up. Paul, I know I've been chatting with you a little bit, and Cliff and Cheryl, you guys have tossed out ideas as well for what to chat about. So I'm going to share my screen here in a little bit. We have some prepared content that we'll go through. I can share a link to you guys. I'll actually just share it to you right now so I don't forget in the chat to a whimsical board. As far as I know, you should be able to view it free without installing anything. Let me know if that's not the case and I don't understand that correctly. This is just ad hoc. You guys understand that. We're here just to study together. So a couple of things I want to call out is to ask questions. And if there's something even slightly out of scope that on something we're talking about, feel free to bring it up and ask. I would rather you get a question answered than me talk about something you already know or already really comfortable with. So if it sparks a question, then ask away. And I'm going to do my best to tell you if I don't know the answer. So ask questions and I'll jot them down so that we can talk about them maybe on Thursday when we have time, because I won't know the answer and I don't want to give you bad information. So I just want to set your expectations there. So does anyone have questions before we begin, or topics that they would really like to talk about either this week or today or on Thursday? Okay. I'm going to move some screens around here. You guys know to speak up. I may or may not see you visually, so you have to actually talk. If you raise your hand in the chat or anything, I won't visually see it probably. And I can go fast, so you just pause me if I need to slow down and go through some concepts again. All right. You guys see my screen okay here?
Yep.
All righty. Good deal. So I'll give you a quick overview of what we're going to chat about. Don't get distracted by some of the things. We're going to talk about forward proxies and reverse proxies. So we'll look at kind of what happens from a network perspective, network architecture perspective, and kind of the differences in use cases. When you get questions that are trying to trip you up on those, you shouldn't have any question about which you would want to use under which circumstances. We have a handful of terms that we're going to cover that got brought up. I don't know how into detail we'll get. So just ask questions if you want to go more in depth in just kind of reviewing terminology and some of the concepts. We'll focus more on use cases, like what problem does this solve? So if you get a test question that's scenario-based, it's usually what would you choose to implement? How would you resolve this? What is best practice for addressing this? Okay, I did not have time to prepare anything for elliptical curve cryptography. I have a couple of links, and you guys, you have this document, so you can click in there if you need to. So there are a couple of videos that I like and use to study on the concepts. So if you have questions, I would love to train on this another time. I just didn't have time to prepare it tonight. And then same thing for key lengths. This is a Google Drive doc. It has kind of a cheat sheet for domain 3, which focuses a lot on cryptography. Excuse me. So for now, use that as a reference. I do want to spend some time finding some memorization techniques to make the key links and all those different algorithms a little bit easier to manage before your test, because it's no fun to just memorize that sort of stuff. And then we're going to talk about Diffie-Hellman too. So if you were here last week, we started talking about asymmetric and symmetric cryptography, and that leads into the Diffie-Hellman exchange. So we'll talk about that a little bit. We'll use kind of a take on the color wheel example, but more of I like the architecture diagrams. Colors are great, but you guys have heard the color side of things. Two other things we didn't really have time to get to. I'm not sure how much time we'll have tonight to spend on it. Software assurance maturity model and the cybersecurity maturity model. Both of those, if we don't get to them today, we'll probably spend some time on that. And there's been a request to cover some laws like GDPR as well. So if we don't get to that today, we'll spend some more time on that next week. Any questions starting out? Does that spark anything of like, boy, if we are talking about ECC next week, I'd sure love to hear about that. Okay. I'm ready for some questions here when you guys are. Let's talk about forward proxies and reverse proxies. First of all, does anyone want to take a stab at giving me a couple of sentences about the difference? Why would you choose one or other? Let's see if someone knows the punchline right away. Okay, so we'll go through forward and reverse proxies from a traffic perspective. So let me see. This will be our packet. So you guys comfortable with the term IP packet as a way to transmit data? That's a term you guys have heard?
Yes.
Okay, perfect. So let's go through this from a traffic perspective. In a forward proxy, what we're going to do is we're going to send the traffic from our client forward out into the internet. So traffic starts out at a workstation and it gets forwarded along to your forward proxy. Your forward proxy acts as a way to then decide where and how that information is distributed. So the client sends a request, hey, I want to go to google.com. Well, the request passes through that proxy. It's kind of a middleman, really. I mean, that's what a proxy is, and just from a language perspective. So it's going to do a couple of different functions at that forward proxy point. First of all, it can just be an anonymizer, similar-ish to like a personal VPN, where you have somewhere, some endpoint that is trusted, safe, secure, that you know, you have some relationship with typically, even if it's just a paid VPN provider in that context. Somewhere trusted that you're going out, and then it goes out to the big, bad, scary internet. So it's an intermediary between it. So there's a handful of different other functions besides anonymity that can take place. But real quick, I have a question. Can or is a proxy a firewall? Help me understand, what is the difference between a proxy and a firewall? Can they be the same? Are they? Should they be in this context? Tell me a little bit about that. You guys will have to jump in on this with me. I know you guys have some guesses. You're going to have to be ready to answer on the CISSP.
Yeah, I'm not sure. Like firewalls do filter based on the packets, IP port, and all stuff. I'm not sure. Proxies can do that.
Yeah, absolutely. So they can perform web filtering, 100%. So let's take the example of a company. A company has a group of clients, their employees in a network, and they want to have some way of filtering employee traffic. Well, I want to make sure they're only going to safe or approved sites, or I want to block certain types of content that might be malicious or unsafe. They can use a proxy in that sense. A request comes to the proxy looks at it, does maybe a packet inspection. It really depends on how deep that goes. And then it decides whether or if or how to pass that information along. Hey, Udaji, did you have something to say?
No. I was
Okay,
just trying to.
So it can act as a firewall. There can be those functionalities. They're really just optional. If you just wanted it for anonymity, then you can do that. If you wanted to add in web filtering, then you can do that. You can also do caching. So again, take the example of a company. If their company is always going out to salesforce.com, they're constantly using that, well, the proxy could cache some of the data that's commonly being loaded into that environment. That could even be connections to other networks. That kind of gets into almost like software-defined networking and some other concepts that we won't go over today. But understand that a forward proxy has this concept of helping you go out to the internet somewhere with a safe intermediary that's going to protect you or apply some set of controls. So that's the forward proxy concept. Let's talk about the reverse proxy concept. Will, good to see you, man.
Yeah, if this does all things, then why we need a firewall?
Why would we need a firewall? Great question. That is an awesome question. So for some small organizations, all of them might actually be the same device. I don't know if I'm going to get it on camera here. I got a little like small travel router. For me, that functions almost as the same thing. It is a firewall. It's my router. It's a wireless access point, and it can be set up as a proxy too if I want it to be. So they can all be on the same device, and sometimes that's okay, especially in small networks. Who can tell me what SOHO, what that acronym is? SOHO.
Small office, home office.
Bingo. Yeah. So Soho routers or Soho firewalls often can have all those functionalities in the same device. You're 100% right. Here's why, a use case why we might not want it to be that way. So we got our firewall. Let's pretend this is our proxy. So pretend with me this is our proxy. So let's say the client wants to come to the proxy. That is going to decide what happens with that traffic. It could be a web filter. Let's say that's the first stage. So it has a couple of different features, and then maybe it gets passed on to the firewall, and that has an additional set of capabilities or features. Sometimes a company might want a firewall and a proxy, because a firewall tends to be built for certain operations, like encrypting or decrypting traffic. It's pretty decent at that. Web filtering, proxies are pretty good at that too. Another reason is just adaptability to architecture changes. So with this, you could have a second proxy and start doing internal load balancing if you wanted to, and have all of those point towards the same firewall. So now you're in a position where you could use proxies a little bit differently inside your organizations. Okay, I only want people that work in this specific office or maybe on this specific subnet to access this information. So we send them through one proxy, and we have load balancers for others. So it's more of a flexibility. But again, to answer your question, they can be the same device. It's just usually the more advanced capabilities and adaptability or scalability for why they would make those separate devices. Same concepts, and this is very similar to a proxy, different, but like a VPN concentrator is also, so it's a different device. All its job, though, is to condense that traffic from VPNs. So it's similar to a proxy in that it's taking all that traffic, it's all that control point, and deciding what to do with it. It's just a specific function of it. Yeah. Great question.
In the real life, even what I have seen is that people or any organization who deploys the proxy, its main purpose is to do proper logging, and even it is to it is like more of to have accounting. Like, let's say if user is doing anything and what he is doing, it is well properly it's like recorded. So when they are going to the internet, it is with their username and everything, it is get recorded in a proxy. Then they may be having firewall in the perimeter label, so that the rest of the packet is again inspected based on your IPS and everything, which I think the proxy doesn't have. It's more of allowing the traffic based on the filter, and even it's man in the middle.
Yeah, man in the middle. That's a good way to put that. So you're welcome to keep talking, Rakesh. This is wonderful.
Yeah, so that is what I have more understanding of your forward proxy. Reverse proxy, which I have seen, is like mainly used in the cases where we have load balancers. Like, when we have internet traffic coming in inside to us, there we mainly use the reverse proxy, like F5, which we have. So any traffic, let's say, that is what I have understanding, but maybe it is in this case that VPN concentrator, which you are saying, which is again, it is, I think, port forwarding on particular port of 443 or something, with the public and private key residing in that.
Yeah, you're 100% right. Thank you, Rakesh. So let's review what he was saying to make sure this is clear. So jump in for questions, because Rakesh explained some of this in a better way. One of the other benefits of proxies, especially in forward proxies, is collection of logs. You're forcing all the traffic to one place. You have a choke point, in a sense, for your logical networks, and it makes it easier for traffic collection and logging. Additionally, another reason is your public IP address. You might not want that sitting on a proxy. You might want something else to be public facing. It also limits the number of IP addresses you might need for internal proxies. And then on the flip side, let's chat about the reverse proxies here. So reverse proxies, Rakesh brought up load balancing. That's a great thing. So let's talk from a high level perspective. What is the difference between a forward proxy and a reverse proxy? Forward, traffic is going out to the internet, out somewhere. How do we control its egress or its forward progression? Reverse, we have clients that are going to come in to our organization. The clients may or may not be trusted. It could be used for accessing websites, and we'll talk about how that would actually look. It could be used for accessing a company intranet. So maybe company employees use the reverse proxy in a sense to access internal assets. So how this looks from our packet perspective, our packet starts out with the client. It's some workstation, could be an employee, could be a stranger, and they send a request to our server. And in this example, let's just use a company website. They want to go, it's like an e-commerce site, and they want to check out. So they go to ecommercewebsite.com. The packet goes along, and that's actually sent to a reverse proxy here. And that may be IP address here. That's typically something that has to happen is you publish something in your DNS records that then tells the internet where to go. So you're telling the internet where to go, and then on that device, you are now maintaining control of traffic again, which is what happens. So your traffic goes through the reverse proxy. It's now sitting on your reverse proxy server. And again, this is the same sort of principle. There can be a firewall at play here. Could be before. That's typically how it would be. It would be before, and it can, in those SOHO instances, be the same sort of device. So the proxy then sends it on to our servers. So once it's at our servers, it does its thing, and then it gets passed back out. But it's keeping the client from being able to talk directly to our servers. And the couple of reasons that would happen, Rakesh nailed one, it's load balancing. If we have a ton of this stuff, maybe it'll start to overwhelm one of our proxies. So we duplicate it and we make another one. And that's, in a cloud environment, this is easy to do. A couple of clicks and you have another one. And then it goes even bigger and you can have another one. So scaling and load balancing is excellent for this. Also, again, you can have content that's maybe hosted or cached on the proxy, depending on how that would work, to speed up the experience of your users. So forward and reverse proxies. First of all, Rakesh, do you have any comments on that? Did I rephrase that well? What did I maybe miss that you thought?
I think you rephrase it correctly. I have one more point regarding the forward proxies.
Yeah.
It's like in this case, you have to have your end user device set up for proxy connections. Like you may be having there is a special kind of file, we call it or maybe you have to set your browser to send the traffic to forward proxy server, and then forward proxy takes from there. Where in case of if you have just a firewall, you don't need to do any such thing. It's like the request goes directly to firewall, and then firewall can send you based on your requirement, like challenge to enter your credentials, and then based on that it can let you to go to the internet. So proxy is like additional step. It is for the administrator or the user to set configure in their end user device.
Yeah, great point. Absolutely great point. Just to rephrase what he was saying, this client, it has to know where to go. Where is my forward proxy? So it has to be configured on the device to know what that proxy is. The exception to that is if it's already sitting in a network that has that configuration taking place. So if you're sitting in your office, you're going to be using their Wi-Fi, or you're going to be plugged in to their network, and it's going to be configured to use that proxy. But there has to be a configuration somewhere, versus on this example, the reverse proxy, the client doesn't need to have anything installed. It's trying to get to the server. It doesn't need to necessarily know where to go. It's reaching out and going through DNS to find that. And we can have another chat about DNS in another session for how that works with this. But in this case, it doesn't need any pre-configuration, just the servers and the reverse proxy. So this is the part we control in a forward proxy, the client maybe. And this is the part we control in reverse proxy. So, and then, yeah, the distinguishing uses. Where is the traffic going, and where is the important data hosted? Here, the data that really matters is from the client. What does the client want to do? That's the only point of this whole diagram here, is the client needs to do something related to the internet or the company intranet or something like that. Here, I mean, the client's request is important, but they want the data. They want what's here. So where is the important data sitting? Is the important data sitting here and needs to go forward, or is the important data sitting here and needs to be recycled back to them? So I'm going to pause again before we move on to some of these terms we had listed on. Forward and reverse proxies. Who's got questions about why you would use them, use case examples, anything like that that you want to chat about before we move on?
Where do your URL rewrites fit within that?
Tell me more about that question, Cheryl. Help me understand that.
I'm not quite sure where they happen.
Yeah.
I thought somewhere near the proxies, but I wasn't quite sure.
Right. Okay. I don't have a good answer for that, but thankfully I have a handy dandy URL rewrites. Okay, perfect. Yeah, I got that question jotted down and can get you a better answer on that.
Thank you.
Yeah, you betcha. Who else has any questions?
Yeah, I got a quick question. Kind of listening in here. That proxy is that you have in your diagrams. Is that a general proxy, or because that isn't there a proxy for like email as well? Like
Yeah, there can be, absolutely. So those are breaking down the services that are going to be offered. So an email proxy would be set up. You would have your email server where all your emails are stored. Let's grab one of these servers. Email servers, that's what these are. Let's pretend these are email servers. We have, we could have an email server. We could have a file share server. We could have, I'm going to have an identity and access management server if I wanted. So the separation there is emails are all stored here. That's where they physically are, or physically, logically are. And when a client, in this case, like a company employee, wants to access their email, they don't get sent directly to the servers. They get sent through that reverse proxy that's configured to grab that. So they don't necessarily know where to go. They don't necessarily need to grab those, communicate directly with the servers. And then reciprocally, when mail is sent to them, mail is sent to the proxy and then sent where it needs to. That's to avoid some of the security concerns. It's also to have logging and web filtering at a different place, because you could do web filtering and things like that at an earlier stage in the process. So short answer to your question is you would have different servers, different proxy servers for those microservices, just because you would want more granular control over what's happening with that traffic. So that's kind of a more simplified answer, I guess.
Gotcha. Yeah.
Okay. So don't think these terms will be very complicated to you guys, but please speak up. So use cases and problem solving, conceptual things like that related to these terms are more important to me than the definition, so that when you see them in a story or an example question, that you'll understand how they fit into the equation, not just the definition. So we want to think about questions like that, not just what is the definition of the term. So NGFW, I know someone is going to fire away with what that acronym is.
Next generation firewall.
Bingo. Okay. So give me, I know I've got some answers right here, but give me some ideas of what does a next gen firewall mean? I mean, everyone talks next gen, about what are the capabilities that it has that a regular firewall, something legacy, might not have. What are the problems that it solves? And so some of the questions you might see on the CISSP are like justifying the cost for this. If you were going to meet with the board of directors and tell them a feature about next-gen firewalls that you would want to include in next budget or whatever that would be. Pick the one that you would not apply or would not be beneficial. We'll have questions like that on there. So tell me a little bit about the differences. Content filtering. I see someone saying content filtering. Yeah, thanks, Annette. Yeah, what else?
Web filtering, application filtering, antivirus. Then you have IPS protection in that. Okay.
Yeah.
And DNS filtering, web video filtering, file filtering. These are all the advanced capabilities of NGFW firewall.
Absolutely. Thank you. So,
and to just summarize this, UTM functionality, Unified Threat Management.
yeah, UTM, Unified Threat Management. That's a great way to look at it. And just to break down that term, it's defense in depth, really, is what that is. We need to take a multi-layered approach, a unified approach of using some different tools and technologies. So a couple of those things, here, deep packet inspection. So we can go into the packet and we could maybe find concerns within flags, look and see if there's potentially data leakage that's going on. Data loss prevention is something that can take place at this point too, trying to identify, is this information that's going out sensitive? Application awareness as well. So it's aware at different levels of the OSI model. So it can actually inspect the different layers, which is great. And then you use the phrase, IPS and IDS. This is something, IDS, intrusion detection system. This can be true of a legacy firewall because that's kind of a broad term, intrusion detection. A security guard is technically an intrusion detection system. So IDS is a little bit more broad. IPS, someone tell me the difference.
One monitors and one monitors and detects.
Yeah, and the difference here is prevention or prevent? Intrusion prevention system. So instead of just detecting, we're also going to take some level of response here. So next-gen firewalls, that's really the key capability that they start adding, is you can start responding in a little bit of a different way. You're collecting more data from more sources, like the application layer, like doing maybe deeper packet inspection, like doing stateful things where you're watching what's going out and then allowing that content back in, but not any other content. So they can perform all these different types of techniques. So your security team would go through the configuration. You as now a CISSP manager are making decisions. How would we configure this next-gen firewall? What sort of capabilities do we want to place on it? Let's see, another one, geo-filtering. So you could apply geo-filtering somewhere.
I got a quick question before you move on, if you don't mind.
Fire away, Paul. Yeah.
You touched on something there I was just about to ask. So the next gen firewalls, they operate, they don't operate at only one level of the OSI model. They operate at like two levels.
Yeah. Let me see if I can find give me 2 seconds to see if I can find something that would illustrate that.
Because I think I remember seeing like a couple of questions on both attempts that I made on the exam. They try to trick you and they say firewall, but somewhere in the language, it's actually referring to a next gen firewall, and versus a traditional firewall, which would operate at maybe just the the network layer.
Yes.
In this particular case, it would be the network. The question they were asking was actually in 2 layers of the OSI model. So you got to pay attention to stuff like that.
I'm grateful you brought that up. Let's just look at this together, and you guys understand we're all learning as we go. So we're jumping into something I didn't prepare. So let's work on it together exactly how we would. We're all
sorry
students.
about that. It just popped in my mind when you.
Oh, I love it, Paul. I would not want you to make any different decision. I'm really grateful. I love questions. So
Yeah.
let's. Oh, sorry. Fire away. I can't see who I interrupted there.
Oh no, it's in it. Paul, yeah, what Paul was saying, I had one that was that they were asking about stateless, was it stateful?
Yes.
You know,
Mm-hmm.
yeah, they had the packet filtering, which is kind of the same thing, right? Like, but they just, you know, they put that in the answers, just try to trick you into, you know, and stateless, whatever they, yeah, I had one of those questions as well.
Okay, that's great to know. So maybe we need to do maybe a study session on Thursday or next week on stateful versus stateless.
Definitely, yeah. Because I remember some of those.
Let's. Holy cow! Holy cow! Why is my keyboard glitching out?
Josh, also I had I know it's off the top. I'm sorry, everybody. I had the EAL, the common criteria questions on that, and then a SOC. A lot of I had like
SOC.
two or three questions on SOC. So,
SOC as in Security Operations Center, or SOC like the compliance standard, SOC 1, SOC 2?
yep, SOC 1, SOC 2, SOC 3.
Excellent. Okay, so stateful versus stateless. 2 L's in that, I guess. Yeah, I'll leave it. Okay, stateful versus stateless. We'll do SOC tool plus other. We'll get a few in there. Okay, great. Anything else you guys want me to jot down while I'm on this end of the page of stuff I can add to my list to cover in next sessions?
Common criteria. I don't know if you've gone over that already, but that's what I had a few questions, like 3 questions on common criteria.
Cool. Awesome. Thank you, Annette. Annette, you were the one that was speaking, correct? I don't have my video up.
Yes.
Awesome. I'm glad that you're here. Thank you. Okay.
Hey, Josh, if you'd check in the chat a couple of things that I just posted.
Okay. I mean,
because she was talking about SOC 1, SOC 2, which could be the auditing aspect, not the security operations center. And also IDS is to IPS, which is what SIEM is to SOAR. So
yeah, great illustration of that, Cliff. Absolutely. Thank you for bringing that up. SIEM and SOAR. Who can tell me, not Cliff, what SOAR stands for?
Security Operation Automation Response. Orchestration, not operation. Security orchestration.
There we go. Yeah, beautiful. Security Orchestration Automation Response. Who can tell me why did Cliff link SOAR with IPS, with intrusion prevention? What is the correlation?
Well, because it has response in there and IPS.
That's beautiful. Yeah. These capabilities get really exciting, especially for like blue team operators who are looking at defense, or purple team. They tend to look at logs a lot, which is wonderful for these. They want to look at raw data. Intrusion prevention systems, so how they work, they're looking at logs. They're looking even at event logs, potentially on individual systems, to find indicators of compromise. IOC, that's an acronym you might see. Indicators of compromise. Does this look like ransomware? Well, researchers have deployed ransomware and looked, what is the first point where we think, yeah, that's an indication that this has been compromised. So that's what intrusion prevention systems and detection systems are looking. And then SOAR comes into place because we're going to orchestrate and automate a response. So, example, let me see if I can use my network. Forgive me, I'm going off the cuff, guys, so we might, my keyboard is not working right. What's wrong with my keyboard? Okay, let's use this example. We're going to talk about honeypots, but we might be able to use this the same way for intrusion prevention systems. So our attacker, let's pretend this is an indicator of compromise. This is the first point in time we think this could be an attacker, or a ransomware, or some sort of an attack. So let me see if I need to make this any different. Am I going to bring it to a different network? No, I'll leave it here. Okay, your attacker is going to come into your real network. Bear with me on the honeypot diagram. I should just have a regular network architecture up somewhere. So indicator of compromise comes into a real network. You have something like a honeypot maybe enabled, and you're able to identify, hey, this is what's going on. XYZ ransomware has been detected, could be in the initial stages, or we're seeing packet sniffing going on, or there was a network scan that happened. There was some indication that happened. So what is our response? Now, in the case of ransomware, it might be, well, let's run this script across all of our devices to cut off network access. So we're isolating the issue potentially. Kind of is going into the padded cell concept. I don't know if I'll have time to get to it, but little sneak peek of what we were supposed to be talking about with this diagram. So that indicator of compromise is then used to orchestrate an automated response. One indicator is seen on an endpoint device, and then a company can use that to orchestrate a response across their entire network or their entire architecture organization. So another example of this might be, well, like a worm would be an easy example of something along those lines. Or this could also take the place of like blacklisting. Let's say there's a malicious IP that keeps attacking people and they don't understand what's going on. People are sitting in the SOC, the Security Operations Center, not the auditing aspect. People are sitting in the SOC and saying the same IP. Well, they can have an orchestrated response to blacklist that IP everywhere. So really exciting things. Another time we'll go more into detail on that because it's so much fun to do labs with SOAR concepts because you get to do purple teaming. You get to see the bad guy do stuff and be like, wow, that was bad. And then you get to do the good guy stuff and like, whoa, it actually worked. So one day. All right, I got a little distracted there. Who's got questions before I move on to Diffie-Hellman?
If you can put down on your list there, like for next gen firewall for topics to discuss, next gen firewall, operational layers, or something like that.
Absolutely. There we go. Okay. All right. Say your question for me again, Paul, so I make sure I'm getting the right thing on my quick notes.
Next gen firewall versus
like the different application layers.
Yeah, because I've got tripped up on that. If I don't know like the intricacies and the differences, and they can throw questions several different ways, and if you don't understand the different nuances, you don't know which one's which and which ones operate at what level, or more than one of the OSI layer.
Okay. Wait, I'm sorry, guys. My keyboard is glitching out big time. I'm not. I need to maybe replace it or something. Sorry if I'm maybe moving around a little slower. Okay, perfect. We will look at that, like OSI firewall versus something that's older. Same. Well, kind of. Actually, let me just move this up here since that's a little more related. Okay, we will go through that so we can clarify what layers, what different types of devices are operating at. Thank you for making sure I got a note on that, Paul. I really appreciate that. I have a terrible memory, so if I don't write it down, chances are I've already forgotten. Okay. So Diffie-Hellman. Last week we talked a little bit about cryptography, and we discussed asymmetric versus symmetric cryptography. So symmetric, we're sharing the same key. We're using the same key to decrypt and encrypt all of our information. Asymmetric, we have two different key pairs, or we have a key pair, I should say, two different keys. One would be a private key pair, or a secret, and then you have your public. And one you use for encryption and the other you can use for decryption, but the same key won't do the same operation and give you a result. So if you use a public key to encrypt something and then use it again to try and decrypt it, it wouldn't work like you use with symmetric cryptography. So that's the major difference. And you guys have all heard Alice and Bob. So we're going to walk through this a little bit for how this works, because one of the things that asymmetric cryptography enabled us to do, and I can't remember who it was, maybe it was Annette or Will last week, reminded us that the reason this is so important is because it enabled us to create a secret key even on a public environment. So one of the things that I would love to do this, I know sometimes I get distracted on wanting to study together and work on labs versus actually making sure you guys are ready for test day. But we could totally do this exercise in chat live one day of have you guys volunteer, and I can give you guys some instructions so you could create a secret key using the public chat. But we'll go through what that concept would look like here visually. We're going to use asymmetric cryptography to establish a connection that's secure so that we have a shared key that we can go back and use symmetric cryptography. So we'll go into the differences and use cases for why we use that in a minute. So we start out. We have Alice and Bob. Alice and Bob at the beginning of this choose a prime base and a number. That is public information. They can share that over the open internet. They're choosing those two things because that's what the algorithm needs to actually make this, in a sense, it's not quite reversible, but it makes sure that those keys can be used together to encrypt and decrypt and give you the same output on the other side. That's the uniqueness of this algorithm. So they start out with something shared. Alice has her key pair. She has a private key and a public key. Bob has the same thing. He has a private key and a public key. So the first thing that they're going to do is they're going to exchange public keys. So they have one secret piece of information, their private key, and one other public piece of information, their counterpart's public key. So Bob has his private and Alice's public, and vice versa. They also have another public piece of information, the prime number here, or the prime number and the base that they're going to use. So they have two public pieces of information. Anyone in the world can know those, but they have one secret piece, their private key. So they're going to combine the same exact elements in here. The reason Diffie-Hellman is unique and the reason it was this discovery or revelation is because you can perform these operations in a different order and get the same outcome. This is why they use color mixing as an example. You can mix colors in any order you want, and you're going to get the exact same output. It doesn't matter how you mix the colors in what order. From a math perspective, that's not always true. You guys have heard the concept of an order of operations. If you do one mathematical operation first, it has the potential to influence later operations. So this is structured in such a way where they aren't dependent on each other. So they can operate in different orders. So it gets a little bit more into the math, but all you have to really understand is that the reason Diffie-Hellman works is because they can perform this math on their own end. They have the one secret piece of information, and they can combine it with the two public, and they get this shared key. Bob can do the exact same thing. He's got this same shared piece of public information. He has his own piece of, or the Alice's public information, and then he has his own private. So they can use that and they come up with their shared key. After that, it's symmetric. They have the shared key, they created it in a secure way, and they've established a connection. This is really common in TLS, transport layer security. When you go visit a website, this connection is taking place behind the scenes to establish that. After that, you can use a shared key, but initially they do that because it's more secure, or it is secure, I should say, compared to asymmetric. So I'm going to pause there. We can talk a little bit more about why you would use one versus the other. Why isn't everything asymmetric? But who's got some questions, comments, or concerns on that before we do anything more?
I have always one doubt in this, that this prime number and prime and base, is it number already? Because when we look into the public key infrastructure, where we have always public key available in the, or we can say public key trusted by CA authority, that is there in all the browser. Now, and private key is mostly it resides in a server or any of these places.
Mm-hmm.
So I was never clear where this prime and base concept comes. I always think that if Bob wants to send message to Alice,
Mm-hmm.
Bob will use Alice's private key and encrypt the message, and it will send it to Alice. Since Alice has his private key, Alice can decrypt the message and can see it. So, Josh, you understood? I didn't use the prime and base at here.
Yeah. So let's walk through that. Let's walk through that. I want to make sure I understand, and we'll make sure everyone's on the same page here. So what Rakesh is saying is Alice knows Bob's public key. It's available. It's available because there are things like certificate authorities. We chatted a bit about this on last week, and so Alice has access to Bob's public key through the certificate authority, or they've shared it in some other way. Certificate authority is almost always how it would happen. You don't know Google's public certificate. The internet does. You can go there and it's published and ready to go for you to grab. So Alice has Bob's public key. She has a piece of data, or let's that she wants to send. So what Rakesh is saying is, why doesn't Alice just encrypt it using Bob's public key and then share it with him? So sending the encrypted data to Bob and then let Bob decrypt it. Bob's got his private key. Then he can decrypt the data and have the answer. And that's 100% accurate. Alice can absolutely do that. So this data, when it is in transit here, so data at rest, Alice hasn't done anything. It's sitting on her computer. She's deciding what to do with it. She uses Bob's public key to encrypt it and sends it. So this is now data in transit. Who can tell me what the issue that we have at this stage is? What principle of the CIA triad might be a little bit questionable at this point?
Confidentiality.
Yeah. So with the CIA triad, this data is encrypted. Absolutely. Let's say someone does intercept it. Well, they also actually have access to Bob's public key. So they could decrypt this data if they want. Anyone, well, oh, actually, you're right. Hold on, let me think about that. Rakesh, thank you. See, this is, I get put on the spot and think about things, and that's...
No, I think just like the biggest advantage of this, the TLS is, right? TLS is a hybrid cryptography, right? It uses the asymmetric as well as the symmetric. So the reason for using the symmetric key is for faster transmission of data, bulk transmission of data.
Yeah.
Right. So that is the reason for the TLS is using the hybrid. So the other asymmetric is used for other stuff like, the what do you call, like, verification of the sender and receiver, mutual authentication and stuff like that. But the symmetric is mainly used for bulk transmission.
Yes, absolutely. You brought up some excellent points there, and let's come back to this real quick, because obviously I have a misunderstanding that I need to correct. So Rakesh, I'm really glad that you brought this up, because I don't have a good answer for you right now, and I want to, because you asked a question that 1000% makes sense to answer.
Yeah, it makes sense. Rakesh said, like, hey, you have a public and private key, like, why can't you use it? Like, that is the reason, like, asymmetric is not fast. And we know, like, symmetric is fast. That's why we wanted to use the symmetric. That's where Diffie-Hellman comes in, like, to create the session secret keys. And how do you share the secret keys? It's by Diffie-Hellman, right? You cannot. So this is a secret way of sharing the session keys.
Yeah, that's great. And Rakesh, I want to make sure that I understood one piece of your question here. Are you saying, why don't we use this type of an operation to just get the symmetric key established? Is that did I understand that piece of your question correctly?
Yes, Josh. And
Yes.
my main question was like this prime and base, why we are using it. Like, since the whole operation is happening because of public and private key. And after once this is done, the CIA will be stabilized. Like you will have, because with the public key, your integrity and your non-repudiation is tested. Now, since it is encrypted, it is like I'm not sure if it is encrypted or not. That is one question again. But because you are doing a this kind of transaction means you are doing a signature, what do you call, digital signature. So
Sure.
your integrity and non-repudiation is tested. Now you can decrypt the message and you can send the now keys or data, right? So that's where I was little confused and wanted to know more on it.
Yes. I'm going to get you an answer next week. I've got that on my list, and I'm going to improve my understanding so that next time I can have an intelligent answer for you. Or if I can't, then I'll hopefully have another resource for us. But that's a really good question.
Diffie-Hellman came in the way that we wanted to exchange the key by not sending the key, but by just sending the the initial prime number, right? The public prime number, right? And then the two people on the other side, they choose their private key, and then they come up with the formula that Diffie-Hellman uses. They arrive at the same results. So that's how the session key is generated. So Diffie-Hellman is not what do you call it's just a key negotiation. It's not a key exchange algorithm, right? So that's how it is create. I mean, it's more of session exchange. Sorry, negotiation, not an exchange. So the secret way of creating a session keys.
Yes, that's a good point. You use the word negotiation instead of exchange.
Exchange, yes.
I think that's going to be key to getting the correct answer for us, Rakesh. So I'm going to jot that down too. Those are just great questions, guys. Great questions. So exchange versus what was the other? Say the other term for me again, please.
Negotiation.
Thank you. Negotiation. I think those will be key to our answer to this question. So I'll have a better answer for us next week on that. And just to refresh our memory on a couple of the things that Sravan mentioned for us, some of the advantages that asymmetric cryptography has in using techniques like this versus symmetric. First of all, it's linked to public and private keys. So there's an element of non-repudiation. I can't deny that I did something with my private key unless my private key was compromised, which defeats the whole purpose of a private key. Authenticity in that same way. If Cheryl and I are having a conversation and we're signing our emails and I'm using my public key to communicate with her, she's using my private key to decrypt my information and such, or she's encrypting using my public key and I'm able to decrypt. All of those things are maintain authenticity the whole time, and also confidentiality and integrity. The flexibility, I've heard this as a question very, very often. I'd be a little bit surprised if you don't have a question on the CISSP exam asking you, there's some network architecture and they use asymmetric, they use it symmetric. Here's the type of cryptography system they use, and one person leaves. How many keys need to get recreated? There'll be different questions like that ask you. And the reason they are trying to trick you up is so you have a single key that is symmetric, but you might have different nodes that are using the key. Oops. So let's look at that. Just, oh man, we're coming up on the end of time. Holy cow, I'm not going to have the time. Okay, we're going to have to get to some of that in another session. See, you guys always run me out of time. I get so fired up and excited. There's more flexibility in asymmetric because if one person leaves, we only lose their public and private key. Everyone else can communicate individually in a secure way. If it's a company using it and they're using symmetric cryptography, if someone leaves and they're only using one key for the entire organization, everything has to be reset using that. Now that's not common, but I want to make sure you understand. If one key is all that's used and it's violated or doesn't have confidentiality in it anymore, then it's useless. Anything that depends on that needs to be reconfigured. So keys are really important, and which is why you often use a lot of different keys for, well, different keys for different services, different accounts, things like that. In symmetric, if you have a lot of different nodes, let's say Will and I want to talk. So we set up a symmetric key. Well, now I want to talk to Rakesh, so I'm going to set up another symmetric key. Well, now what if I leave the group? Well, we lost a couple of different keys that became useless. So those would be some questions just to keep in mind of who has what keys are getting used. It can be faster to set up because only one person or only one individual or entity, you just need to create one key pair. So it can be a little faster to set up. The negotiation is a piece that can take time, but It also is more secure for a lot of these reasons that we're talking about. And it uses 2 keys too. And to circle back around, and I'm going to wrap us up here, to what Saravanan was saying, one of the things that it also does is, let's see, I lost my train of thought here. Well, what was the last thing that I was going to go for? Some more secure. Oh, darn it. It was one of your better points too, Saravanan. I'm sorry, I forgot it. Well, I'll remember it if I can and jot it down on my list. Okay. Whew. It is time. I want to be respectful of your guys' time. So I want to make sure that I'm starting when we say we're going to start to the best of our ability and ending when we say we're going to end. So I am available for a few minutes afterwards if you guys would like to stick around. I see Rebecca hopped on, so there's some people I haven't got a chance to talk with. So thank you.
Hey,
Josh,
real quick.
Yeah, fire away,
this is for the group as well. You guys think maybe we need to increase the time to an hour and a half, or is that not good for everyone?
I'll let you guys speak. You guys
Or you want to pass that by Vincent or something?
I'm good with that. I'm good with that.
Okay. Yeah. Well, what about if I structured
But
something?
we need to take a vote.
Have an optional half hour on the tail end of it for more like discussion or trickle, like whatever we didn't get to. Really, does that sound something reasonable?
Yeah, Josh, like we can't we like just yeah, we know like we want to understand the concepts, right? Can we also go through like questions that way like we learn more about the concepts?
Absolutely. Like when you say questions, like practice questions.
Yes, practice questions, right?
Practice
yeah,
questions.
because like anyone, I think people might understand the concepts, but when it comes to the question, they're I know I'm struggling.
Yes.
Everyone will be struggling.
You're 100% right. I've got my
Yes.
practice question book right in front of me. So you're 100% right. We need to do some. So maybe that's something we could do. Maybe focus on an hour of going over material, questions about the material, and then do like 30 minutes so we could walk through some practice questions.
Yeah,
together.
that would be better. Yes, that
Okay.
would help.
Yeah,
Yeah.
I would like that too, for sure.
Okay. Awesome. I love that because I love getting to like the questions. That's what we're studying for. And sometimes I can get a little distracted. So having some time to work on questions would be nice. Okay. Let me jot that down here. Because again, oops, 3 minutes. That's all we get. 3 minutes of questions. Okay. Well, awesome. I'm going to call it quits there. But if you guys want to hang out, I can just off the cuff read a couple of questions and we could go through maybe one or two if you want. Probably not for half an hour, but if you guys want, I could just pick a couple out for us. Does that sound? I'll let you guys choose. You can hang out if you want or pop smoke and get on with your evening. Cool.
Yeah. Yeah.
All right. So we have talked a good amount about cryptography lately. So let me find some cryptography questions for us that we can go through. All right. So I'm going to read it. I'll probably read it twice. Yeah, I'll read it twice. So think about it and we'll chat about it together. So Brian is computing the digest of a single sentence of text using a SHA-2 hash function. So I'm going to say that part again. Brian's going to get the digest of a piece of text, and he's going to use the SHA-2 hash function. He changes a single character of the sentence and computes the hash value again. So he changes one character, and then he's going to take the hash value again. Which of the following statements is true about the new hash value? First, does anyone have questions on the question itself? I'll read it through one more time, but does the question make sense? He hashes something, he changes a digit or something in there, and then he hashes it again. We good on that? Okay, so I'm going to read the 4 options we got here. New hash value will be 1 character different from the old hash value. Don't put any comments or anything like that or anything like that. We'll wait right to the end. In fact, I'll see if I can set up a poll. I don't know if I can do that, but I think there's a way to do that. I'm not going to spend the time on that right now. I'll figure that out offline. Won't I? How fast can I figure it out? I can figure it out fast. Okay, I'll type up the answers for us after I give them to you. So a new hash value, at least one character different than the old hash value. The new hash value will share at least 50% of the characters of the old hash value. C, the new hash will be unchanged. Or D, the new hash will be completely different. I don't want to know what the answer is. I want to know why the answer is what it is. Someone already said D. Yep. Tell me why is it D? Why is it every character changes?
This is how the hashing algorithm works. So hashing is mainly for the integrity. So what happens is like when you input one data to the hashing algorithm, new I think it is a fixed digit code will be generated, and it will be always totally different than the previous ones. I think
Yeah.
Sarvana has mentioned avalanche effect. Avalanche is, I think, something different, right?
Well, I'll touch on your point. It's the avalanche effect is kind of at play to a degree here, especially if we take into consideration using a salt or a nonce or initialization vector. But we'll focus on this for now. But you're right in your comment about the avalanche effect. I don't know if that was Rebecca or Annette that posted that. But yes, so to jump to your point about hashing, the point of hashing is to validate the integrity, at least in this concept. He has a file, he takes a hash, he changed something. He's violating the integrity of that. He's taking another hash. The hash should be completely unique. Any given input should result in a completely unique output. The exceptions lead to attacks like rainbow tables or hash clashing or crashing, whatever that term is. Those are violations of the security of hashing or using that against a hash. But yeah, non-repudiation, integrity is the key word with hashing, and a uniqueness of the value. So it's not going to be just one character change. You changed only one character in the document, but it ran through that algorithm with that change, and that avalanche effect, so to speak, came into play, and the entire thing looked completely different. So, okay. That was an easy question. Let me skip through here. Oh, I don't even know the answer to that one. We'll go to that another day. Okay. Yeah, this is a good one. If Richard, I'm not going to use Richard. We got Alice and Bob. If Bob wants to send an encrypted message to Sue, so Bob wants to talk to Alice, and he wants to use public key crypto system. Public key crypto system. Someone use a different phrase or word for that.
Asymmetric.
Yeah, asymmetric. Yep. PKI, public key infrastructure, is another term. So when you come across terms like that, public key crypto system, they might try and change their phrasing to try and trick you. So just, you can take that pause and just be like, what are they talking about there? Oh yeah, PKI. We're talking about asymmetric cryptography. All right, bingo. So Bob wants to send a message to Alice. Whose key does he use to encrypt the message? So we got here's our four options right here. Let me zoom in on them. Here's our four options. Ignore this.
Alice public key.
Yeah, tell me why. Walk me through what happens. He's using Alice's public key. Why doesn't he use her private key?
If he use private key, like he cannot use it because he
can't use it. Yeah, okay, perfect. So we've eliminated one option. He can't use her private key. He shouldn't have it. So why doesn't he use his private key to sign it? Could he?
But the message is going to Alice, right?
Yeah, if Bob signs his message, or if he encrypts his message using his private key and send it to Alice, what's the problem with that? Is there a problem with that?
Yeah, she won't be able to decrypt it.
Yeah, if he sends it with his private key, she technically can decrypt it.
Oh yeah. You're right. Because all public keys out there.
Yeah. So what's the problem with that? Because she can decrypt it. Why doesn't he just do it that way? He's got his private key. It's sitting right next to him on his desk.
They're not supposed to share private keys.
Yeah. So it has to do with this aspect. Bob's public key, it's public info, anyone has access to it. So if he signs or if he encrypts something, uses it using his private message, the only thing he's done is prove that he's the one that encrypts it, because he should be the only one that has that. So that's authenticity at play. If he sign, or excuse me, I keep saying sign. If he encrypts it with his private, and she can encrypt it with his public, but it's not confidential. It's encrypted, but everyone, the whole internet has Bob's public key. So he can't use his private key. But yeah, I think it was Sravanan mentioned he can use Alice's public key. Yes, everyone has access to her public key. He can go grab that and he encrypts the data. Now, no one else can decrypt it. Even Bob cannot decrypt that email that he just sent. So if he sends a piece of data and encrypts it using Alice's public key, the only person in the world that can decrypt that is Alice with her private key. So we kind of jumped the gun on that question a little bit. I guess we just kind of walked through the answer more than giving you guys a chance to actually answer. I'll have these actually written up and some polls ready for us next week. But so you guys understand why we use the other person's public key in this. Okay, cool. Let's see if we get
you explained that pretty good there. You're right, because it's open to the internet if he uses. Okay, gotcha.
Yeah, exactly. So you just want to think, okay, I can sign it with whatever's publicly available, or I keep saying sign. I can encrypt it with whatever is publicly available, but who is going to be decrypting that? I want to make sure that that step in the operation is limited to whoever should be doing that. Yeah. Okay, those are about bits and bytes. So you guys have requested some info helping with bits and bytes with the different algorithms and hash cryptography stuff. I'm working on something, but I want to make something that's actually usable. You guys can look up a table of that and memorize it, but I'm trying to think of a way where we actually could be productive looking at that. So that's coming someday or another. Okay. So we're going to do the reverse of this. I'm not going to talk. Someone else is going to explain it. Bob gets a message that's encrypted from Alice. Whose key is he going to use to decrypt that message? So it's encrypted when it gets to Bob. What does he use to decrypt it?
His own private key.
Yeah, his own private key. Bingo. If Alice did things the right way, she encrypted it with his public key. So now he's going to decrypt it with his private key. Yeah, bingo. Okay. Yes. All right. This is going to... I'll read this question out. It'll be a little bit slow. So Bob wants to digitally sign a message he's going to send to Alice. And he wants to make sure that Alice can validate that the message came from only him and that it wasn't modified in transit at all. So I'm going to pause. What aspect of the CIA triad did I just identify there? I don't want this information modified.
Integrity.
Awesome. Yep, bingo. Thank you, Will and Cheryl. Okay. So he's going to digitally sign the message, sending to Alice, and he wants to make sure that integrity is not violated. Which key should he use to encrypt the message? Integrity is the most important thing with this. Yeah, he can do that.
Wait. I'm sorry. To encrypt the message?
To encrypt the message. This is a little bit tricky. So let me go grab my message thing here. I got a message. Didn't I have a message? Where's my message? Holy cow. This sprawls. You poor guys. You're so patient putting up with me. Okay. So yes.
So yeah, I will take back. It's going to be the public key.
So Bob wants to send a message to Alice. He wants to make sure integrity isn't violated. So hashes are important, and we're talking about signatures. Let's refresh our memory on what a signature is. Does anyone want to take a stab at it? What are the critical elements that make up a signature?
It's the hash.
Hash. Yep, absolutely. What else?
Hash to be signed with the private key.
Yeah, so we need the private key, and we also need CA, a certificate authority. Typically, almost always you would have a certificate authority in this sort of a thing, because you need a way to get the private key. This is in more corporate type communications. So I just don't want to make sure, I want to make sure you guys aren't forgetting there's a certificate authority behind the scenes that's helping this PKI, public key infrastructure, identify who is who. It's public, it's a certificate authority. Like DigiSign is an example of, I think that's the company, DigiSign. There's a lot of different ones, but they're authenticated. Google is who they say they are. So we're going to give you a certificate that you can post on your website that says, I am Google. That contains their public key, not their private, obviously, but it contains, oops, I already, public. So certificate authority has that public key, is maintaining it, published on the internet. So signatures is what we're getting at. Let me put signatures at the top so I don't forget. Okay. So signatures, what happens when Bob and Alice are sending an email together? Bob has his text for his email, and he is going to encrypt the email, and he is going to encrypt it the same way he always would. He can encrypt it using Alice's public key if he wants to, so that she can decrypt it using her private key if it's that type of an email. But what he does with the signature is he can take and he gets the hash value of the email or the text. So the hash is first. Alice and Bob are in the background. Their cryptography or their cipher suite is being negotiated. So that's happening on the back end. We can talk more about cipher suites another day, but they've already negotiated a hash value that they agree on behind the scenes. So Bob hashes this. What he does with the hash then is he encrypts the hash with his private key. So anyone can decrypt this though. So it's not confidential, is it? What is the point of this? He just encrypted his hash of the email. What does that allow Alice to do? So she's going to get this email. She can decrypt it if she uses the public key infrastructure that they've set up, but she wants to validate that it's actually from Bob. She got this text and she got a signature, is all. So what good does this do, Alice? What is going to be going on in the back end of this?
Verification by the PKI?
Yeah, so there's a verification element that's taking place. So what happens here? The text is going to get sent over to Alice. It's encrypted. She can take the same hash of that text. She has the same way to do it. They agreed on a hashing algorithm. Well, how does she know that the hash hasn't been modified, or that the text hasn't been modified? Because let's say she received bad text.
Just gonna compare the hash, right?
Yeah. If she takes the hash, how does she know it's good? How does she know it's the same thing that Bob sent? And that's where this signing comes into place. Bob encrypts the hash and he gives that. So he has instead of just a regular hash, she has an encrypted hash and the original, because she can take the original anytime she wants from that text. She can then decrypt, though. She can decrypt this hash using Bob's public key. So he encrypted the key. This is a little complicated, so forgive me if I repeat myself a couple of times. Ask questions if it's not clear, because I'm explaining some of this off the cuff, so it's not really as structured as you guys can tell. But we have our email. Bob takes a hash of the email, and then he encrypts the hash. So we don't know what the hash is exactly. We can't see what that is. We're going to send the email to Alice. Alice has that we don't know what it is hash because it's encrypted. She can hash that same email text, though, and decrypt the encrypted hash, because she can decrypt it using Bob's public key. So now she has something that she can compare this to. She can compare the hash that she took with the hash that Bob signed to the email. that he encrypted and signed. I know this is what it is because integrity has not been violated on it. So this is a way behind the scenes that she's validating those two hashes, I guess I should say. Is this text that I received that has this hash the exact same as the encrypted hash that Bob sent me? I'll check and decrypt it first using his public key. So that was a long, I don't even remember the original question. Holy cow, you guys see I get off track so often. All right. Does that make sense? What questions or comments or concerns do you have on that?
But the question was asking, like, what is the key that the message can be encrypted, right? That's what was the question.
Like, tell me more about your question because I want to make sure I understand.
No. The question that you asked, right, from the book, I was asking. Yeah.
Thank you. Yes. Okay. So let me read the question again, since we've been off track for 10 minutes here. Bob is going to sign a message that he's sending to Alice, and he wants to make sure that Alice is positive the message came from him and was not tampered with. Whose key is she going to use to decrypt the hash? What is she going to use to decrypt this? Whose key?
Bob's public key.
Bob's public. Bingo. Yep. He signed it. He signed the hash, or encrypted the hash with his private so that she can unsign it. Or, unencrypt it with that. Yeah. Nice job. Okay. Let's see.
Okay. So she uses Bob public to verify the hash, correct?
Yeah, exactly.
And okay, so as far as the text, she's going to use her private key to decrypt the text, right?
Exactly. So it could be, it's a little, and I'm glad you brought that up, Paul, because I don't think I clarified that. It's not explicitly stated in the question, but in reality, there's two of these going on at the same time.
Right.
Or there can be. The text, the actual email body is one thing. They can use this normal PKI to do that exchange. Confidentiality is ensured using that, and to a degree, non-repudiation is as well, or because they're using asymmetric cryptography. So the distinction here is we're focusing on integrity of the message. So that's one encryption that's taking place here at the text level. This stage is taking place on the hash, validating the integrity and making sure that the hash wasn't altered either. So I'm glad you brought that up, Paul. I don't think I really called that out. Two different encryption processes that are taking place using one. Alice needs Bob's public key to do, Bob is signing, keep saying signing. Bob encrypts this with Alice's public. She can decrypt the email with her private. Bob encrypts the hash with his private, and then Alice decrypts the hash with Bob's public. So there's two different ones that are going on in the background at the same time.
Don't worry, man. We get it. This is this whole stuff. I'm pretty sure we're all, we all got caught up in that mess as well.
Yeah.
From beginning to end. But you
Thanks for
did a
sticking
pretty
with me.
good job.
I appreciate you guys' patience. I get to learn with you guys. If you guys don't know, I'm starting a job. I work as a compliance and risk analyst right now, and I just got a part-time job teaching at a university. So you guys get to be a little bit of my training wheels. I get to learn how to teach, and your feedback just makes the biggest difference. So, okay, let's look at another question. Good job on that, because understanding that distinction, they asked you, which one does she use to decrypt? Decrypt what? Decrypt the digest. The digest is another term you'll use for that, or you'll hear for that hash value. So if they had said to decrypt the text or the body of the message, then that's a different answer. So again, this is where they're trying to trick you up. There's two 100% correct answers. The difference is that one word. What is she decrypting? So I'm really glad you called that out, Paul. Thank you. Okay, you guys got one more question in you?
Yeah, sure.
Oh boy. Yeah. Ooh. That's not a term. Okay, I'm going to ask the question. The term is not some. You guys are probably more familiar with the term than I am because you're actively studying. So this is a refresher term for me. So the question: what type of cryptographic attack rendered double DES? Let me jot these terms out real quick for us here. Whoa! Oh man, come back. There we go. Whew. All right. That's what I'm after. So, ooh, that's ugly. Oh no. Oh no. Sorry, guys. Okay. So, DES. This is an encryption algorithm. Oh, you already got it. Well done. Meet in the middle. Okay, you read my mind. You read my mind for where we're going. We have DES. We have double DES. And we have triple DES. Someone, not Saravanan, since you already spoiled it for us, tell me, distinguish these for me. What is double DES versus DES? What is triple DES versus DES? Help me understand the difference between those.
Round of encryption, three rounds of encryption.
Exactly. Rounds of encryption. This is one of those things that is relevant when we're talking about key lengths, bit lengths for encryption standards. How many times do we run it through that algorithm? So I'm not going to go into DES specifically, but it's one round. Double DES, you guys are pretty smart. 2 rounds. Triple DES is 3. So
aren't 1 and 2 deprecated or not used anymore?
Yeah, absolutely. 100%. You're exactly right, Paul. And the reason is the meet in the middle attack, which is what I think I put in the chat. Meet in the middle. Now, someone knows the answer to this. Ignore triple DES for right now. Focus on single and double. If I'm a hacker and I want to crack single DES versus double DES, and I learn, oh, there's some technique I can use called meet in the middle. Help me understand what that means. Why is meet in the middle such a great attack for this? Why does it make it so much easier for me to crack double DES? It should be way harder to crack.
I'm not sure about how they're cracking it, but I think that the way that the 2 keys are created, one key is created, and the second, by the time the second key is created, some people are like, getting that first key.
Yeah. Yeah. So we have our gobbledygook, our cryptographic text here, whatever was encrypted, and we have the, well, actually, excuse me, plain text. So I don't remember the details, and I can jot this down in my notes to talk about next week because I know we're just about out of time. But if you're a hacker and you're going through 1 round of encryption, you want to break 1 round of encryption. Let's just say it takes 100 units of effort for you to do that. Well, now the good guys, darn them, they decided to run 2 rounds of that. So instead of 100 units of effort, it doesn't just take me 200. The math says it should take me another 100 times longer than that. I'll include some math on this in the next one to make sure I'm actually speaking correctly, but stick with me on that. It should be another 100 times. So instead of 100 units of effort, I need now 10,000 units of effort in order to crack this. Man in the middle says, well, I need to go one direction. I need to do 1 round of encryption. I know another round of encryption happens to get me here. Well, what if I start an attack here at the plain text and an attack here and try and meet in the middle? So it's, to Saravanan's point, it's being able to perform operations simultaneously at the same time versus only in sequence, 1 at a time. I can only run 1 brute force attack at a time. I'm brute forcing from both ends. So I'm not explaining that well because I can't tell you where they would get plain text because obviously they don't have the plain text if they're doing this unless they have like a sample set. So there's a gap in my knowledge here that we can chat about next time. But for now, understand it's a way of using how cryptography is applied against itself. we do 2 different rounds. So we're going to attack at 2 different points so we can double our resources. We can attack 2 problems at the same time instead of having to wait to solve another problem. We can work twice as fast. Or it's actually not twice as fast. It's scalably as fast within that. So, yeah. Guys, we're at the end of time. I'm going to take off and go hang out with my wife. But thank you, guys. I really do appreciate you being here. I appreciate your patience. And I appreciate your guys' willingness to take time out on an evening and the middle of the night for you guys, too, and studying for you guys at CISSP. So be active in the community. That's my biggest ask of you guys. Knowing what you guys want to learn, hearing practice questions, anything like that makes the biggest difference. Keep it up. Keep it up. I'm looking forward to Thursday with you guys.
Thank you, Jeff.
Cool, guys. See you later.
Yeah.